Good morning. Today we are making the video for packet number 3, which is due not on the 4th as it says on the packet because we don't have school that day. It is due on the 5th. Our first page. The area of Michael's bedroom is 108 square feet. So remember, area means the length times the width. Its length is 3 feet longer than its width. So the length is 3 more than what the width would be. What are the length and the width? Well, we know length and width, if we multiply them together, it's going to be 108 square feet. And we know that our width is our length is 3 more than the width. So when we're looking at this, let's say if our length and our width were 10s, 10 times 10 equals 100. That's just something I know. So I'm going to use that to work with it to see how close I can get to 108, but these two numbers need to be 3 apart from each other. So I know it's going to be close to 10s, because 10 times 10 is 100, and 100 is close to 108. So I might think to myself, what about 10 times 13? Because those are 3 apart. So if my length was 13 and my width was 10, 10 times 13 is 130. Ooh, that is too big because I want it to be 108. So then, do I need to go bigger or smaller with my length and width? Smaller. So you do some guessing and checking. You keep them 3 apart, but you do it smaller numbers. Does that make sense? So you need to find the length and width. All right, our next page is another word problem. Oh, goodness. Another word problem. So we have a logic problem for this one. So I need to set this up. Eli, Marty, Jim, and Ann each own one of the following pets. So I have Eli, Marty, Jim, and Ann. And they each own a pet. So I'm going to make my table. They could own a hamster, a fish, a dog, or a cat. So I want to make my table to figure out who owns which pet. So now I know Eli and Ann are allergic to cats. So are they going to own a cat?
No.
No. So Eli's not going to have a cat, and Ann is not going to have a cat. So I'm going to put X's there. Then it says neither Eli nor Jim has a fish. So Eli doesn't have a fish, and Jim doesn't have a fish. Marty has a hamster. They're giving us one. Marty has the hamster. So what does that tell us about Marty and the other pets? Adeline? He doesn't have any other pets. We're going to cross those off. What does that tell us about the other people with the hamster? Can anyone else have a hamster? No. So we have to cross that hamster off for everyone else. Does that help us narrow down some of our choices? So see if you can figure out what somebody else has, crossing off for the other people, and narrow it down so you can see what pet Eli, Marty, Jim, and Ann have. And over to the side here, you need to tell me. Eli has this, Marty has this, Jim has this, and Ann has this. So your final answer should have their names with their pets over to the side. Our next page is our 5-card challenge. 5-card challenge, just like normal, you need at least 12 points. And they need to equal, when it's an ace for the 5-card challenge, it equals just 1. So all of our equations that we come up with need to equal 1. Our next one is our pattern page. So for math 6, we just have to complete for the total blocks. So we just have to do this column. How many blocks are in figure 1? Say it out loud for me. How many in figure 2?
3,
How many in figure 2?
4,
I had a lot of people saying 3.
5,
There's 1, 2, 3, 4 in figure 2. How many in figure 3? Not 8. Yeah. I think some of us are forgetting to count the pink one. Don't forget that pink one. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many in figure 4? 16. Now, here's the fun thing. I have favorite numbers. Have I told you guys what my favorite numbers are yet? My favorite numbers are perfect squares. What are perfect squares? Adeline? No. Well, 4 is a perfect square, but how do we find perfect squares?
4 equal sides.
A square has 4 equal sides, but when a number is a perfect square, what do we do to find it? Right? So your guys are thinking area of a square. So side times a side. If it is an actual square, it's the same number. So when a number is a perfect square, we would say 1 times 1, 2 times 2, 3 times 3, 4 times 4. Those are our perfect squares. We're squaring the number. What is 1 times 1?
1,
What is 2 times 2?
4,
3 times 3?
9,
6 times 6, or sorry, 4 times 4.
16.
Oh my. Look over here. 1, 4, 9, 16. Figure 1 is 1, figure 2 is 4, figure 3 is 9, figure 4 is 16. Are you guys seeing a pattern?
Yes.
If you take your figure number and you square it, you get your total blocks. Very often in our pattern pages, you will see patterns having to do with perfect squares. This one, all you have to do is figure out the perfect squares for each number. Okay? You need to finish that column. That's it. Finding those perfect squares, following that pattern. Helen? We only have to write something on the answer line when we have a question being asked over here. There's no question being asked this time, so you don't have to put anything on the answer. Our next page is the goofy shape page. First thing we have to do is the perimeter. Remember, the perimeter is adding up all of the sides. First thing you have to do is figure out measurements for each side. Not all sides have a measurement listed, so you need to find those measurements. We know if it's straight across from one, it's going to be the same measurement. We know there are 3 inches up here, so we can figure out what those 2 on the side are because we know it's 9 altogether. We know this one is across from this one. Fill in all of your measurements for each side, then you add up all the sides for the perimeter. Our measurements are in inches, so our perimeter will be in inches. Then to find our area, we can't find an area of a goofy shape, so we need to break it into 2 shapes that we do know. We can break it into a square and a rectangle. Find the area of the square, find the area of the rectangle. Both of them is length times width, so find those 2 areas, add them together, and when we have inches times inches, our measurement will be inches squared. So find your two areas and add them together, and that's the area for the whole goofy shape. Next page. Our next page has a triangular prism. Now, we've been working with rectangular prisms. With the triangular prism, to find the volume, it's similar to what we did for a rectangular prism, but we have an added step. We need to divide by a half. Our base times our height times our length. So we've got the base, our length, and our height going up. And we need to divide it by 2. Because a triangle is half of a rectangle, the triangular prism is half of a rectangular prism. So we divide it by 2. So to show to that calculation, 1/2 times that base of 5 times the length times the height. You do that math and you put the answer right here. We had 3 inches that we were multiplying, so our answer will be inches cubed. That's a little 3. Write that a little better. Then we have to answer for math 6. What is the sum of the lengths of the figure's edges? Note that the height is not an edge. So we have the 3 edges here, the 3 edges in the back, and then our 3 long edges. You need to add all of those up. When it says sum, it means we're adding. So add all of those edges up. Your answer will go here. And when we're just adding, it's going to be just inches. So add up all 9 edges. Figure out what those measurements are if they're not listed. And then add them all up. And that will be your edges for the whole shape. And our last page. We have some data that we need to look at. So for math 6, it says, which time slot was most affected by the introduction of the 11 p.m. news? Which time slot was the least affected? So let's look at our data. We see the 1 o'clock news is that blue line. So this is the 1 p.m. news. The 6 p.m. is the yellow. The red p.m. is the 9:30 p.m. The red line is the 9:30 p.m. And then the 11 p.m. is this green. We can see that it starts after a few months. So look to see what happens to our data lines on how many people were watching the news. And then what happens when the 11 p.m. news becomes an offering? Which programming gets hit the most? Which programming was affected the most? That line moves the most. You're going to put that answer here. Which one was affected the most? And then which one wasn't really affected at all? That line didn't really change. You'll put that to answer the second question, which time slot was least affected? So which line doesn't change the most? It's not affected. So that's your second answer. Which one moved the most? That one's the one that's most affected. So you need to tell me which time slot. Okay. And that is it for packet number 3. If you are watching this at home and you have questions, make sure you come see me. If you turn it in by this Friday, you will have an opportunity to fix any mistakes that you made. I hope you are well and have a wonderful day.